Okay. So I'll be starting the class. Before you go up with this particular concept, before you go for the particular program of stack implementation, now let's we revise the conditions of the stack. Okay. So what are all the conditions and to be applicable for the stack? So first is, what is stack? Stack is a data structure. So it is a data structure which will be opened at one end. So it will be opened at one particular end. So that where insertion and deletion will occur at the same end. That is called as a stack. What is stack? Is a data structure where insertion and deletion of the elements will occur at the same end. So that is called as a stack. So inserting the elements, we call it as push operation. So deleting the elements from the stack, we call it as a pop operation. And we have a pointer called top. So what is a pointer? Top is a pointer. So top is the pointer which you are going to make the topmost element of the stack. So what the pointer will consist of? Top is a pointer which consists of the address. Okay, so it consists of the address of topmost element in the stack. Okay, so now after that, after push operation, after pop operation, now you come for the two conditions. One is overflow condition, the second one is underflow condition. Overflow condition means when stack is full. When the stack is full, if you insert an element, so then what will occur? Overflow will occur. When the stack is full and you are inserting the element, then you will get it as overflow condition. So that one we call it as overflow. Okay. So next you come with a underflow. What is underflow condition? When you are deleting the elements, when you keep on deleting the elements, so if you are deleting the entire stack contents, if there are empty, stack is empty, then we call it as underflow. So underflow means there is no element to delete in the stack. At that time we take it as underflow. Understood? So next we come with a conditions. So under push you will be having overflow condition. What is a overflow condition? If top double equals size minus 1, then we take it as overflow condition, that is stack is full. Understood? So when you take it as a stack is overflow condition, when topmost element double equals size or size minus 1. Okay, so you can take it, the size will be the last element. Okay, so size will be the maximum number of element. If top double equals size, so it is a condition for overflow. Similarly, if there are no elements, so top will be equal to -1. So top double equal size means topmost element, that is the last element of the stack. So top double equals -1 means no elements in the stack. At that time we call it as stack is empty. Understood? That is a condition for underflow. So are you understanding? Are you getting these concepts? Getting overflow and underflow? Understood this? Overflow and underflow. So again, I am telling you, kindly understand this overflow and underflow conditions. So overflow will occur when stack is full. So over means the size, that particular size is been full, and if you are placing the elements for the full stack, so at that time we call it as a overflow. So at that time, what will be the condition? Top double equals size or size minus 1. Okay, top is the pointer which points to the topmost element. So if the topmost element is equal to size, what is size? It is a maximum stack size, maximum element of the stack. So top double equal size will mark you as overflow condition, and top double equals -1 will mark you for underflow condition. So these are the two conditions you have. Okay. So that's when now you come for this particular program. So coming for the particular program that we are implementing the stack using arrays. Okay. So it is a program what you have in your lab set program. So kindly go with a stack. Okay. So start with this part. So it is starting with stdio.h, and I have defined a stack with the elements as, so how many elements are there? So maximum stack size is 10. So initially there is nothing in your stack. So stack is empty. That's why we point top is equal to -1. So while you are going to insert now the elements. So elements into the stack. So as there are no elements, stack is empty. So stack is empty means top is the point variable which have the value -1. Understood? So why you give the value -1? Because there is no elements in your stack. That's why we are giving it as top is equal to -1. Understood? So now you start with a come for this part. So first, this is the function for pushing the elements. Okay, so this is the function for popping the elements, and this one is the function for display. Okay, display the contents of the elements. So actually our program will start from main. So from main you have to start the program. Okay, so what is the stack size we have taken? So it is 10. Okay, so first I will initialize the stack. So stack of size comma data comma ch. So what is this? So we go with a so you start with a stack of size comma data comma ch. Okay, so while of 1. Okay, that means you are starting with the condition as true. So how many operations you have going to do? So that the first operation is push, second operation is pop, third operation is display. Okay, so now for that I am going with a new one, enter the choice. So here you have to first insert the element, next you have to delete the element. So for that one it will tell enter your choice, push, pop, 1 for push, 2 for pop, and 3 for exit. Okay, so read the choice. So how many choices are there? It is 1 and it is 2. Okay, so only 2. Where is the display? Display will come in each and every push operation as well as in pop operation. Okay, so that's why we have now taken the display here. Only when you push the element, you are going to display the stack. When you go for the pop the element, you are displaying the stack. That's why there is no display operation taken. Okay, so first option is push, second option is pop, and third one is exit. Okay, so scan this choice. So what choice you will be giving first? So you will always go with push operation. So once the element is inserted, then only you can carry the pop operation. Okay, so once you push the element, insert the element using push function, then only you can remove the element using pop function. So what is to be done? Pop, first you insert the element. So that's why the scanf, you scan the choice. So what is the choice? Choice is 1 for push operation, choice is 2 for pop operation. Understood? So if ch double equals 1, so ch double equals 1 means push. So what you are going to push it here? We are going to push the data. The data is nothing but element. So that's why I have taken a printf and the scanf. So enter the data to push, and it is scanned using ampersand data. Okay, so after that, now you call a function. So this is the calling function used for push operation. So this one we take it as, so it is a calling function you use for the push operation. So that means what the push will be do. So in order to push the elements, so this is the calling function, and this one, now the control will move here. Okay, so what is the control? From, it will move from, so it will move from calling function to called function. Okay, so which is the calling function? Push of stack data. So whereas this one we call it as called function. So calling function will be inside the main and called function will be outside the main. So that's why we're taking push of stack comma data. It is a calling function. So this will come here. What you are pushing? We are pushing the data into the stack. Okay, so into the stack. So take the same thing. Int stack comma data is been considered as int item here. Okay, so it is only the arguments we are going to change. So arguments is getting changed. So first, when you go for the insertion, so first you have to check for overflow condition. So what is the condition for overflow? If top double equals size or size minus 1. If top double equals size or size minus 1, then we take it as stack is full. Okay. So what we tell it is, if top double equals size minus 1, then we take it as stack is full. So that means you are checking for a overflow condition here. Okay, so if top double is not equal to size, so what you are going to do it here, increment the top and move the item into the stack of top. So this is the condition you can take. So I have already told you in the previous class, during insertion, if you want to add an item, so top is to be incremented and that place the item is being placed. So first increment the top, make the room to place the item. Okay, so first you have to increment the top and make the space to insert your item. So this has created, top plus plus has created, so it has created space to insert the item. So it is created the space to insert. So now you make stack of top is equal to item. So this once you create the space, so here you can place the item. Okay, so this is the condition for push operation. Okay, once you push the elements, so once you push the elements, next you can go with a display function. Okay, so you have to start from where? So display from topmost element of the stack. So display from topmost element of the stack. So come for the display function. Display of stack, it is a calling function and this one is called function. So stack contents will start from where? So it will start from top and it should go up to 0th element. Minus 1? No. So start from topmost element and it should go with a 0th element and keep on decrementing. And this is the syntax. So stack of 0, stack of 1, stack of 2, stack of topmost element, stack of top minus 1, stack of top minus 2, top minus 3, like this. It keeps on decrementing. Understood? So that is the display function. Okay. So from where we are displaying the elements? We are displaying the elements from the topmost element of the stack. Understood? So similarly, that is up to push and display. Now you come for the else part. So which is the another part? CH double equals 2. So CH double equals 2 means you are going to pop the element. So here you see I am directly calling the function pop of stack. Okay, so pop of stack. So come for the, this is the pop of stack is the calling function. So from there your cursor will come to the outside function. So it is in this part. So first you see here int d. First you point with what is d? It is the deleted element. Okay, so d will be the deleted element. So before you delete, what is to be checked? You have to check for the underflow condition. What is the underflow condition? Top double equals -1 is the underflow condition. So if this is the case, what you will be doing? If top double equals -1 means there is no element in the stack. So at that time you go with a stack is empty. Okay. So it will return nothing because stack is empty. If top is not equal to -1, if top is not equal to -1, then delete the topmost element. So that's why we are taking stack of top is equal to D. So stack of top is equal to D means you are deleting the topmost element. So once you delete the topmost element, we are represent top is equal to null and D we decrement the top. Okay, so this is the condition. So point to the topmost element, the D will be the deleted element. So now your point stack of top is equal to null. That means there is that part will be deleted. So what you have in stack of top, that will be placed to null. So once your null means you have deleted that particular item. So once you delete, it is a empty box. Okay, well, the empty box now which is pointed by top should come down. So that's why we take it as top of minus minus. So keep in your mind while inserting, you increment the top and place the item. While decrementing, while deleting, you delete the item and decrement the top. So this is the conditions. Okay, so what is the conditions? You go through here, it is top plus plus and stack of top is equal to item. So here stack of top is equal to null and top minus minus. So these are the two lines what we use here. Okay, so this is top minus minus. So first delete the item and decrement the top. Here increment the top and place the item. So that is the conditions. Okay, so that is after that you are displaying. Once you pop the element, again you go with a display function. Understood. So if CH1 or CH2, so CH1 is for push operation and CH2 is for pop operation. Else come for the last case. If CH double equals 3, break. So break means it will come out of the particular loop. So which loop you are in now? You are in the while loop. So while loop it will come out. Okay. So this is the program. Come for the output part now. So come for the yellowish part, it will be the output. So first choice, 1 for push, 2 for pop, 3 for exit. So first I will give the element 1. So enter the data is 22, stack contents is 22. Again, I am going with a 1 for push, 2 for pop, 3 for exit. I am calling the function value 1. So you are inserting 33. So what is the stack contents? So stack contents are 33 and 22. So now again you go up with a insertion. So again you have taken the option as 1 and you have inserted the value. So inserting the values, so we are giving it as 44. So that you have inserted. So now you display the contents. So displaying the contents, you get 44, 33 and 22. Again, now you see you are giving the option as 2. Option as 2 means it is pop operation. So pop operation means which one will be deleted? The topmost element. So topmost element is 44 and that will be deleted. So now the stack contents are 33 and 22. Again, you take the pop operation. Popped item is 33, so stack contents is 22. So when final you give it as 3, it will come out. So this, now you understood this particular program. Understood? So if understand, now tell me the condition. So tell the conditions to insert. So tell the conditions, what are all the conditions to insert an item? Tell the conditions for insert operation. So first condition number 1, so it will be check for overflow. So condition number 2, it is increment the top. So condition number 3, place the item. So place the item on top position. So these are the 3 conditions. So first condition is check for overflow using top double equals size. So next condition is increment the top. So that is using top plus plus. Then place the item on the top position, that is using stack of top is equal to item. Understood? So similarly, tell the conditions. So tell the conditions for delete. So what are all the conditions for delete? Similarly, you can tell it. Once you have written for insert, it will be very easy. Okay, check for underflow. Next. So, no. So it is first condition, check for underflow, okay. But second condition, decrement top is no. So once you check for underflow, next you have to delete the element. So understand here. So first one is underflow. So second condition is delete item. So third condition is decrement top. So these are the 3 conditions you are going to have it. So for insertion, first is overflow, next increment the top, next you go for placing the item. So for this you go with the underflow, delete the item and decrement the top. So these are the conditions. Understood? So understood all the conditions? Okay, so now you come for the next concept, the stack in the dynamic array. So this is the next concept you are having. So in the previous we have gone with only the array concept. So now you go with a dynamic array. So dynamic means it is dynamic memory allocation. So anybody can, so it is the dynamic memory allocation. So which are the dynamic memory allocation methods? So which are dynamic memory allocation methods? Which are the dynamic memory allocation methods? Malloc, next calloc, realloc. Okay, the same thing. So same thing, now you use it in this particular program here. So come for the program part now. So Same thing, you are taking size. So int size, and you are taking it as int top is equal to -1. Okay, you have not defined the size. So here you have to give, so int size is equal to 10. So here you see, you give it as int size is equal to 10. So top is equal to -1. So all the same operation. Come for the push. So first check for overflow. Next, increment the top, place the item in the top. So similarly, come for the pop operation. No change will be there in this program. So pop operation, first check for the underflow condition. Next, delete the topmost element and decrement the top. So come for the display. Again, the same thing. You are displaying the elements from top of the stack. So for that, you are taking it as x is equal to top, greater than or equal to 0, x minus minus, you are printing all the statements. But where you are coming across the word dynamic memory allocation. So come for this part. So in main, so first you see, here you see, in the previous program, we have given hash define size 10. Okay. So for now, you have not taken any size. So you are giving it as int size. So keep in your mind, it is int size only. You are not given any size of the stack. Okay. So for that, I am taking int star of stack. So that means it is a pointer. So it will take how many elements that we have to see next. Okay, so you don't give stack of size, it is star stack. So because it is a pointer which contains the maximum elements. So in printf, you give how many elements, and thus here you are scanning the size. So this printf is for, so you are reading the size. So you are reading the size here. So next, after that, now you see, now I am calling the malloc operation. So this is the dynamic memory allocation. So we are taking for malloc. So here we are using dynamic memory allocation. So this is the only line. So remaining parts, what you have, channel CH1, CH2, CH3, everything is same. Okay. So first choice is for push, next choice is for pop, and third one is for exit. So first enter the data and push and display. Similarly, pop and display. So these are the conditions you give, but only change you are having is, so no size is given, and here you are giving the its size. Okay, so now you are allocating how much size. So here if you give it as number of elements or size is 10, so how much the bytes of data is been allocated. So it is size of int is 2 star 10. So 10 star 2 is equal to, so it will allocate 20 bytes. So it will allocate 20 bytes of memory. So that's one we are telling here. So how many bytes are allocated here? It is 20 bytes will be allocated for this one. Understood? So this is the program on using stack in dynamic array. Okay. So keep in your mind, rather than going for the program, first you understand this part. So this part are very, very important for all the engineering concepts you study, because everywhere you come across the word stack. Okay. So stack will have push and pop operation. So these are the conditions. So understood this particular program? Same program, but only changes this part. So this is the, what I am marking here, this part will be the changes you will be having. That means you are reading the size. But in previous program, so here you have defined the size. That is the only change. Okay. So now after that implementation, now you see where this stack are applied. So come for the part stack applications. So which are the stack applications you have? So these are the parts. So first one is recursive function. Next is expression evaluation. So that we will see in the next coming lectures. So you will be having evolution of expressions. Next, checking the parenthesis matching, conversion of one from to another, backtracking problems. Next, language processing. So support for recursion. So all these are applications of stack. So very important concept. So which are those? Recursive function, evolution of expression, checking parenthesis matching, conversion of one expression to another, memory management, backtracking. So next you have language processing. Next, so you have wearing or removing bangles. Next, support for recursion. So these are the programs, applications where you are making use of stack. Understood? So this is up to stack applications. So all this particular video link that will be shared in my YouTube channel also. So you can go through the YouTube link, and these are the textbook and references we have gone through. So I hope you got understood. So have you understood all this program and concepts? Was my voice is clear? Okay, this is up to this particular lecture. I will be I will be uploading that in my YouTube channel. You can go through easily if you have got any disturbance. Okay, so here I will be ending my particular sessions. So if you have not filled the attendance, you can fill it here. Okay, so I will be up to here. So thank you all for my lecture. Kindly go through my YouTube channel and subscribe for the channel and understand all the concepts. Thank you.